Good morning, everybody. I hope everybody's staying warm and cozy. Please remember that today is a snow day. Though, of course, being a snow day, it's not really being used as a snow day. Instead, it's distance learning, which will count towards our total number of contact days. So we won't be using this day or having to make this day up in the spring. Alrighty, guys. So today we're going to review types of reactions in preparation for our test that is coming up. The five main types of chemical reactions are synthesis, decomposition, single replacement, double replacement, and combustion. We know that there's a couple other names for double replacement and single replacement, like single displacement and double displacement. Double replacement also has the name precipitation reaction. Synthesis and decombination are also known as combination and decombination reactions. Synthesis reactions are where synthesis is going on to combine different things. Synthesis reactions in chemistry involve the joining of two atoms and/or molecules together to form completely new compounds. The synthesis reaction generally follows this pattern that you can see here, A plus B, arrow, A, B, aka if you have one product, this is a synthesis reaction because it has combined your reactants. Decomposition reactions, however, are essentially a larger compound as your reactant that breaks apart into smaller substances, usually two, maybe more though. This is essentially the reversal of what happens in the synthesis reaction and follows the pattern that you can see below. AB, arrow, A plus B. Oops, went too far, guys. We also talked about single replacement reactions. In a single replacement reaction, the cation, usually a metal in a compound, is replaced by another more reactive metal. They always follow this format, though of course, your element and your compound can be switched. Just remember that your pure element switches places with the first compound. But going back to the formula, A plus BC, arrow, B plus AC. We also learned, of course, though, with single replacement reactions that they do not always occur. It depends on the reactivity of the pure element and the metal in the compound. Activity series is what we use to determine this reactivity, and it's used in single replacement reactions to determine if the reaction will occur, and in oxidation reduction reactions to determine the direction of electrical charge. This is a shorthand activity series, as you can see, the top being most reactive, the bottom being least reactive. And we follow these two rules for determining whether a reaction will take place. Highly reactive metals prefer to be a part of a compound, and highly stable metals prefer to be alone. Essentially, this means that if a metal is more reactive, this is the pure element metal, it will replace the other metal in a compound because the other metal is more stable when alone. Double displacement reactions. In a double displacement reaction, the cations of two compounds will switch places, forming two completely different compounds. In this case, note that it's the first element in the compound for both of these compounds that is switching places. AB plus CD, A and C are switching places, giving you arrow CB plus AD. Indications of a reaction taking place in double replacement reactions generally, reminder, it's generally occurring between two substances in aqueous solution. And in order for a reaction to occur, one of the products is usually a solid, precipitate, or gas, or a molecular compound such as water. Gases and liquids can sometimes be predicted, like if you know that oxygen or hydrogen is one of your products. Well, actually, no. If you knew one of the products that you had was just a pure liquid like H2O, you could predict it was a liquid as opposed to aqueous, or in prose to solid or liquid, solid or gas. But solids can be predicted by following the rules of solubility that we have looked at so far. Reminder, soluble substances are able to be dissolved, while insoluble are not able to be dissolved, aka they remain solid. Soluble is aqueous. Insoluble substances are solid. There's some additional types of reactions. We're going to see these later on, but not for your test. There's oxidation reduction reactions, a special type of single replacement, acid-base reaction, special type of double replacement reaction, exo and endothermic reactions. Potentially, these can be all reactions. We'll talk about that when we get to thermochemistry. Be familiar with the symbols used in chemical equations, arrows, states of matter, and conditions in experiment. The arrow, also known as the yield arrow, is used most frequently to indicate a reaction occurring, basically your reactants to your products. Your reactant should be on the left side and your product should be on the right. The reversible or equilibrium arrow, it is a combination of two half-headed arrows facing each other. This indicates that the reaction is reversible and that the length indicates whether products or reactants will be more at equilibrium. For the most part, I think you guys will mostly see similar lengths or the same lengths on both sides. But sometimes the top arrow may be shorter than the bottom, or the bottom may be shorter than the top. State of matter symbols, guys, we should be familiar with these, but as a refresher, these are the symbols that go after the compounds in your chemical reaction to indicate the state of matter that each compound is in. Parentheses around S indicates solid, parentheses around L indicates liquid, parentheses around G equals gas, parentheses around AQ is an aqueous or dissolved in water solution. Note that soluble substances would be aqueous. We also talked about how to identify conditions in experiments. Words and symbols and compounds can be written over the reaction arrow to indicate special conditions to complete the reaction, such as the need for catalysts or heat. The presence of catalysts like platinum or hydrogen, you would write that symbol above the arrow. Or if you needed conditions of heat, you could indicate it with a triangle, or you could write the word heat. Additionally, you could write conditions of light or radiation by writing these or indicating with symbols like HV or HY. That's just an example. Alrighty, guys, stay warm and have a great day.